Imagine, if you will, a distant future. A future so far from now that our own time seems like ancient history. The night sky, our familiar canopy of stars, might look very different. Humanity, or whatever we become, could be scattered across countless worlds, warmed by alien suns. This isn't just a fantasy from a science fiction story. It's a potential destiny, a path laid out for any civilization that survives long enough to grow up. The universe is vast, filled with an incredible amount of energy. The story of a civilization is the story of learning how to use that energy. It's a journey from the cradle of a single planet to the infinite expanse of the cosmos. Our own journey has just begun. We started small. Our ancestors huddled around campfires, using the chemical energy stored in wood to keep warm and cook their food. That was our first great energy discovery. Then came the power of wind and water, turning mills and pushing ships across oceans. The Industrial Revolution unlocked the immense energy trapped in fossil fuels like coal and oil, building the modern world we know today. Each step was a leap forward, a new level of mastery over our environment. But these are just the first, tiny steps on a much grander staircase. The universe has so much more to offer, a cosmic banquet of power waiting for a species intelligent and wise enough to claim it. The journey ahead is long, and the challenges are immense. To grow from a planetary species to a stellar one, and then to a galactic one, requires more than just technology. It requires vision. It requires cooperation. It requires a deep understanding of the laws of nature and our place within them. The cosmos doesn't care about our borders, our politics, or our squabbles. It operates on a scale of time and energy that dwarfs our everyday concerns. To advance, we must think on that cosmic scale. We must see ourselves not just as inhabitants of a small blue dot, but as citizens of the universe, with a shared destiny written in the stars. So, how do we measure this incredible journey? How do we mark the milestones of a civilization's growth? A brilliant astrophysicist named Kardashev gave us a way. He created a cosmic yardstick, a scale to classify civilizations based on one simple, powerful idea: how much energy they can use. This scale doesn't measure how smart a species is or how beautiful its art is. It measures its power, its ability to shape its environment on a planetary, stellar, and even galactic level. It's a roadmap to the future, showing us the incredible possibilities that await us if we can continue our climb up the great cosmic ladder. In 1964, a Soviet astronomer named Kardashev was thinking about the search for extraterrestrial intelligence, or SETI. He wondered, if there are other civilizations out there in the galaxy, how could we find them? He reasoned that a truly advanced civilization would need and use vast amounts of energy. So much energy, in fact, that its signature would be visible across interstellar distances. He proposed a simple classification system, a way to categorize civilizations based on their energy consumption. This system, now known as the Kardashev scale, gives us a breathtaking glimpse into what the future of any species, including our own, could look like. It's a ladder of technological and energetic achievement. The scale originally had 3 main levels, or types. A Type 1 civilization is a planetary power. It has mastered all the energy resources of its home world. This includes all the sunlight that falls on the planet, the geothermal heat from its core, the power of its winds and oceans, and everything in between. They are the true lords of their planet. A Type 2 civilization has graduated from its home world. It can harness the total energy output of its host star. Imagine capturing every single photon of light and every particle of energy from our sun. That's the power of a Type 2 civilization. They are masters of their solar system. A Type 3 civilization operates on a scale that is difficult for us to even imagine. It has learned to control the energy of its entire galaxy. That's the power of not just one star, but hundreds of billions of stars, all harnessed for the civilization's purposes. They would be able to travel between star systems as easily as we travel between cities. They could colonize countless worlds, reshaping entire regions of the galaxy to suit their needs. They would be true galactic masters. The scale is so vast that thinking about it can make you feel small, but it should also make you feel inspired. It shows us what is physically possible. But why stop at a galaxy? The universe is much bigger than that. Later thinkers, expanding on Kardashev's original idea, proposed a Type 4 civilization. This hypothetical super civilization would be able to harness the energy of the entire universe. They could manipulate space-time, tap into the power of supermassive black holes, and perhaps even draw energy from sources we can't yet comprehend, like dark energy. And some even talk about a Type 5, a civilization that could control multiple universes or the multiverse. These ideas stretch the limits of our imagination, but they are rooted in the laws of physics. They represent the ultimate potential of intelligence in our cosmos. So, what would it actually be like to live in a Type 1 civilization? Imagine a world where the word energy crisis is a forgotten relic of a primitive past. A Type 1 society has achieved complete mastery over its home planet's energy budget. This means they capture and use all the solar energy that strikes the Earth's surface. Every day, our sun bathes our planet in about 174 petawatts of power. That's 174 quadrillion watts. It's more energy than our entire global civilization currently uses in a whole year, delivered every single hour. A Type 1 civilization would waste none of it, using vast solar arrays in deserts and floating on oceans to drink in the sunlight. But their power wouldn't just come from the sun. They would tap directly into the planet itself. They would have geothermal plants that reach deep into the Earth's molten core, drawing up immense heat to power their cities. They would command the weather, not just predicting it, but controlling it. They could create rain for deserts and calm the fury of hurricanes, redirecting that massive atmospheric energy for their own use. The power of tides, waves, and winds would be fully harnessed by incredibly efficient turbines and generators integrated seamlessly into the environment. A Type 1 world is a world in perfect, managed harmony with its planet's energy systems. Life in such a world would be profoundly different. Cities might be self-sustaining marvels of engineering, with buildings that generate their own power, recycle all waste, and manage their own climate. Global transportation could be nearly instantaneous and virtually free, powered by a planetary energy grid. There would be no need to burn fossil fuels, ending pollution and climate change for good. The focus of society could shift from mere survival and resource competition to higher pursuits, art, science, exploration, and understanding the cosmos. A Type 1 civilization has solved the basic problems of living on a planet and is ready to look outward. Where are we on this scale today? The famous physicist Michio Kaku estimates that our current civilization is at about Type 0.7. We still primarily rely on burning dead plants and animals, fossil fuels, to power our society. We have begun to tap into solar, wind, and nuclear power, but we are far from mastering our planet's full potential. Scientists estimate that, at our current rate of growth, we might achieve Type 1 status in about 100 to 200 years. It's a huge challenge, but it's within our reach. It represents the next great step for humanity becoming true caretakers of our planetary home. The jump from a Type 1 to a Type 2 civilization is one of the biggest leaps imaginable. It's the difference between controlling a single house and controlling the entire power plant that serves a whole country. A Type 2 civilization doesn't just use the energy that happens to fall on its home planet. It goes to the source. It captures and controls the total energy output of its parent star. For us, that would mean harnessing the entire power of our sun. The sun radiates about 384 yottawatts of energy. That's a 384 with 24 zeros after it. It's a number so large it's hard to comprehend. It's roughly 1 billion times more energy than what reaches the Earth. To put that into perspective, think about this. If you could capture all the sun's energy for just 1 second, it would be enough to power our current global civilization for millions of years. A Type 2 civilization wields this stellar power casually, every single moment of every day. With that kind of energy, the possibilities become almost godlike. They could easily move planets from one orbit to another. If their home star was aging and becoming unstable, they could regulate its output, or even move their entire solar system to a safer neighborhood in the galaxy. They could vaporize dangerous asteroids or comets in an instant. The projects of a Type 2 civilization would be on a truly astronomical scale. They wouldn't just build cities, they would build entire new worlds. They could construct artificial habitats, giant spinning cylinders in space known as O'Neill cylinders, providing comfortable living space for trillions of individuals. These habitats would have their own ecosystems, weather, and simulated gravity. With near limitless energy, They could also engage in interstellar travel, sending massive starships, perhaps even robotic probes, to explore nearby star systems. They would be the undisputed masters of their entire solar system, with outposts and industrial centers on every planet and moon. For such a civilization, the concept of resources would be fundamentally different. They could perform stellar alchemy, using immense energy to fuse lighter elements into heavier ones, creating any material they needed in vast quantities. There would be no scarcity of matter or energy. The main limitation would be the laws of physics themselves. This is the stage where a civilization truly breaks free from the constraints of its home planet. It becomes a stellar species, with its future no longer tied to the fate of a single, fragile world. The solar system becomes their backyard, a playground for their ambitions. How could any civilization possibly capture all the energy from its star? It's a monumental engineering challenge. In the 1960s, the physicist Freeman Dyson imagined a solution. He proposed a hypothetical megastructure that would enclose a star to capture its energy. This structure is now famously known as a Dyson sphere. It's honestly one of the most iconic and awe-inspiring concepts in science fiction and future speculation. The idea is simple in principle. If you want all the energy, you need to build a collector big enough to surround the source. But, the execution would be the greatest construction project in the history of any civilization. A common misconception is that a Dyson sphere would be a single, solid shell around the star. This would likely be gravitationally unstable and structurally impossible. Instead, a more realistic concept is a Dyson swarm. Imagine not a solid shell, but trillions upon trillions of independent solar collectors and habitats, all flying in a thick, coordinated formation around the star. Each collector would absorb sunlight and beam the energy wirelessly to where it was needed, whether to planets, artificial habitats, or giant industrial facilities. It would be like a vast artificial asteroid belt, but one designed for power generation, not just orbiting rocks. Building such a structure would require an incredible amount of material. Where would it all come from? A Type 2 civilization would likely have to dismantle entire planets, perhaps Mercury and Venus in our solar system, or even the gas giants, to get the raw materials needed. They would need armies of self-replicating robots to mine asteroids, moons, and planets, process the materials, and construct the swarm components. The project would take centuries or even millennia to complete. It would be a gradual process, starting with a single ring of collectors and slowly expanding over generations until the star is completely enclosed, dimming its light from outside observers. The completion of a Dyson swarm would mark the true birth of a Type 2 civilization. The civilization would now have a steady, almost infinite supply of power. This energy would fuel their expansion throughout the solar system, power their supercomputers, and drive their interstellar exploration efforts. For astronomers in other star systems, the star would seem to disappear from the visible spectrum, but it would blaze brightly in the infrared, radiating waste heat. This infrared signature is one of the things SETI researchers look for. Finding such an object would be clear, unambiguous evidence of an advanced, star-faring civilization at work. If the leap from Type 1 to Type 2 is staggering, the jump to Type 3 is almost beyond comprehension. A Type 3 civilization no longer thinks in terms of planets or stars. It thinks in terms of galaxies. This civilization has learned to harness the energy output of its entire home galaxy. Our Milky Way galaxy contains an estimated 200 to 400 billion stars. A Type 3 civilization would control the power of all of them. The energy at their command would be billions of times greater than that of a Type 2 civilization. They would be, for all practical purposes, the immortal masters of their galactic domain. How would they achieve this? The process would likely be a slow and steady expansion over millions of years. Having mastered their home star system, they would venture out to nearby stars. They would send self-replicating probes, often called von Neumann probes, to neighboring systems. These probes would use local materials from asteroids and comets to build new industrial bases, and, eventually, new Dyson swarms around those stars. Each new star engine would provide the energy to build more probes and send them even further. It would be a chain reaction of colonization, spreading across the galaxy like a wave. For the inhabitants of a Type 3 civilization, The galaxy would be a single, interconnected society. Travel between star systems, even those thousands of light years apart, would be routine. They might use wormholes, shortcuts through space-time, or warp drives to travel faster than light, if the laws of physics permit. Or they might simply upload their consciousness and transmit it as data at the speed of light to a new body waiting in a distant system. Their population could number in the quintillions, living on countless colonized planets, artificial worlds, and inside the Dyson swarms themselves. They would be a civilization of many worlds and many species, united by a single galactic network. With galactic-scale energy, a Type 3 civilization could perform feats of astroengineering that seem like magic to us. They could orchestrate the orbits of stars, moving them to avoid dangerous cosmic events like supernova or collisions with other galaxies. They could even tap into the immense power of the supermassive black hole at the center of the galaxy, Sagittarius A*. By feeding matter into its accretion disk, they could extract energy with incredible efficiency. A Type 3 civilization would be so powerful and so widespread that it would be almost indestructible. The death of one star, or even 1,000 stars, would be a trivial event for them. What lies beyond the galaxy? The universe. And what lies beyond a Type 3 civilization? A Type 4. This is a level of advancement so profound that it pushes the boundaries of speculation. A Type 4 civilization, sometimes called a universal civilization, would command the energy of the entire observable universe. This includes the energy of all the galaxies, all the quasars, and all the mysterious phenomena we are only just beginning to discover. They would not just be masters of a galaxy, they would be masters of the cosmos itself. Their power would be truly ultimate, limited only by the fundamental laws of physics. To access this level of energy, a Type 4 civilization would need to tap into power sources that are currently theoretical for us. They might harness the energy of black holes on a cosmic scale, not just the one at their galactic center. They could potentially extract energy from the very fabric of space-time. One of the greatest mysteries in modern cosmology is dark energy, the force that is causing the expansion of the universe to accelerate. A Type 4 civilization might understand what dark energy is and how to harvest it. This would give them a power source that is, for all practical purposes, infinite. What would such a civilization do with this unimaginable power? They might be able to manipulate space-time itself, creating new universes with customized physical laws. They could potentially reverse the effects of entropy, the tendency for the universe to become more disordered over time, ensuring their own immortality. They might even be able to survive the end of the universe itself, whether it ends in a big freeze, a big rip, or a big crunch. A Type 4 civilization would be a cosmic architect, capable of engineering reality on the largest possible scale. Their existence would be intertwined with the fate of the universe itself. Is such a thing even possible? We don't know. A Type 4 civilization might be a purely theoretical concept, a logical endpoint of the Kardashev scale that can never be reached in reality. Or perhaps the universe is already home to such a being, its existence so subtle and so advanced that we are completely incapable of perceiving it. They might exist in other dimensions or operate on principles of physics we have yet to dream of. The idea of a Type 4 civilization serves as the ultimate thought experiment, pushing us to consider the absolute limits of what life and intelligence can achieve in our universe. The Kardashev scale is more than just a fun way to categorize imaginary aliens. It's a mirror. It forces us to look at ourselves, at our civilization, and at our future on a cosmic timescale. It provides a sense of direction, a roadmap for what humanity could become if we manage to survive our technological adolescence. Right now, we are a civilization in conflict with its own planet, squabbling over the last dregs of fossil fuels, while the immense power of our sun shines down on us largely unused. The scale reminds us that there is a way out and a way up. The challenge of reaching Type 1 is a unifying goal for all of humanity. Thinking about these grand futures inspires us. It fuels our curiosity and our ambition. The dream of becoming a multiplanetary and then interstellar species is what drives much of our scientific research and space exploration. Programs to develop fusion energy, build better solar panels, and explore Mars are all small, early steps on the path toward becoming a Type 1 and Type 2 civilization. The scale gives us a context for these efforts, showing how they fit into a larger story of human progress. It encourages us to think big, to tackle challenges that seem impossible today, because we know what incredible rewards lie on the other side. The Kardashev scale also serves as a profound warning. The transition between types is likely a perilous time for any civilization. The power needed to become a Type 1 civilization is also the power to destroy our planet through nuclear war or environmental collapse. This is sometimes called the Great Filter, a hypothetical barrier that most civilizations fail to pass. The scale implicitly asks us a critical question. Do we have the wisdom to manage the power our technology gives us? Can we overcome our tribal instincts and work together as a planetary species to solve global problems like climate change and resource scarcity? Our survival may depend on it. Ultimately, the scale connects us to the cosmos. It suggests that the evolution of intelligence and technology might be a universal process, a path that other species on other worlds may have already walked. When we search the skies for signals from extraterrestrial life, we are searching for our peers on the cosmic ladder. Are there other Type 0.7 civilizations out there, facing the same challenges we do? Have any made it to Type 2 or Type 3? Finding one would be the greatest discovery in human history, proving that we are not alone, and that a long and wondrous future is possible. The journey up the Kardashev ladder seems daunting, a climb of millions of years. But we may have an accelerator, a tool that could dramatically speed up our progress: artificial intelligence. AI is not just another technology, it's a technology that can improve itself. An advanced AI could help us solve some of the most complex problems standing between us and a Type 1 civilization. It could design hyper-efficient solar collectors, manage a global smart grid, create new materials, and unlock the secrets of clean, limitless energy like nuclear fusion. AI could be the catalyst that propels us to the next level. As we look toward becoming a Type 2 civilization, the role of AI becomes even more critical. Designing and building a Dyson swarm is a logistical and engineering challenge of astronomical proportions. It would require coordinating trillions of robotic workers, managing complex orbital mechanics, and processing unimaginable amounts of data. This is a task perfectly suited for a super-intelligent AI. It could orchestrate the entire project, from mining the first asteroid to switching on the final collector, allowing the civilization to achieve in centuries what might otherwise take millennia. AI could be the master architect of our stellar ambitions. Furthermore, AI may be essential for managing a civilization that spans star systems. A Type 3 galactic empire would need a network that could manage information, resources, and travel across thousands of light years. An AI network could serve as the galactic brain, the operating system for the entire civilization. It could also be our ambassador to the cosmos. An AI could analyze cosmic data to find other life, and it could be the first to attempt to communicate with an alien intelligence, processing languages and concepts that might be utterly foreign to the human mind. It might be our partner in our greatest adventure. The path ahead is not guaranteed. The same AI that could help us build a utopia could also pose an existential risk if not developed wisely. The future will be a race between our growing wisdom and our growing power. The Kardashev scale gives us the destination, a vision of what we can achieve. Technology, especially AI, gives us the vehicle to get there faster than ever before. It is up to us, this generation and the ones that follow, to steer that vehicle with care, with foresight, and with a shared sense of cosmic purpose. Our destiny is not just on this planet, it is out there among the stars. And the journey begins now.